So we are going to talk about composition of two functions. Remember that composition of two functions is different from multiplication of two functions. For example, let's discuss this through examples. We have two functions f of x equal to x and g of x is equal to x plus 2. Let's keep f of x as x square. Now if we have to compose two functions f and g, first of all its notation will be f naught g of x, f composition g, which could be simplified as f parenthesis g of x. So this not symbol is changed into parenthesis. Now we are going to call g of x as the inside function and f as the outside function. So what you do is, first you deal with the inside function. I'm going to put the value of gx because gx is an inside function, which is x plus 2. Now that we have dealt with the inside function, which is g of x, now it's time to deal with the function f. And for the moment we will forget this argument. Now the outside function f, which we are going to deal with now, is x square. So we are going to write the outside function f as it is, except for where there is x in that function. For example, the function f is x square, so we will write just square and we will leave the space for x. And in this missing space, we will put whatever is the argument in the previous step, which is x plus 2. So we will put it here. You can simplify this by using a plus b whole square formula. X square plus 4 plus 4x. We know the formula a plus b whole square is a square plus b square plus 2ab. So this is how we compose the functions. We can also compose g naught f. So again, naught is changed into parenthesis. It's written as fg of f of x. We deal with the inside function first. Inside function is f of x, so we will put the value of f of x, which is x square. Now we will forget this x square, and now the time is to deal with g. So we will write down the outside function g, and the g function is defined as x plus 2. So we will leave where there is x some space plus 2. So outside function is written wherever there is x, we will leave it as it is, putting some placeholder plus 2. And now in this space inside the parenthesis, we will put the argument in the previous step, which is this one, x square. So we will put x square here, and that is how we compose g naught f. Let's look at another example. Here we have f of x equal to x square, and another function is g of x, which is 1 over x. And we are going to compose f with g. So we will write f naught g of x. We will open this, f composition or parenthesis inside function inside g of x. So f is the outside function. First we will deal with the inside function. We will put the value of the inside function, which is g of x, and in the place of g of x we will put x. Now we'll forget this argument for the moment and write down f, the outside function. The outside function is x square. F is x square. So we will write the outside function, but wherever there is x, we will just leave the space, and this left space will be filled with this whole argument, which is 1 over x. So our answer is 1 over x square. The same way you could compose g naught f, but we will consider another example. You can try for practice g naught x. So we have f of x plus 7, and we have g of x as, let's say, 1 over x plus 20. Now we are going to compose, let's say, g naught f. First, when we open this becomes g parenthesis, this naught is changed into parenthesis, and the inside function. First you deal with the inside function and then go outside. So inside function is f of x, and f of x is defined as x plus 7. Now time to deal with the outside function. Outside function is g, and g is defined as 1 over x plus 20. So here in this step we will write g, but wherever in g there is x, we will just leave a space and we will write complete g. Sorry, this is 20. In this missing space, what are we going to put? It is this argument, x plus 7. So x plus 7 gives us 1 over x plus 27. That's how we compose this. We can try f naught g as well. F naught is changed into parenthesis. Let's put the inside function first, which is g of x is defined as 1 over x plus 20. And now we will put the value of the outside function f, and f is defined as x plus 7. So for x we will just leave the space plus 7, and in this missing space we will put this whole argument, which is 1 over x plus 20. So we have 1 over x plus 20 plus 7. We can simplify this by taking LCM, which is x plus 20, 1 plus 7x plus 140. And finally we can write it as 7x plus 141 over x plus 20. This is how we compose the functions, and for practice you can try this exercise. If one function is 1 over x plus 1 and another function is x square over x minus 1, you can try to find g naught of f of x. So this is how we compose two functions, and the same way we can compose even three functions. So in the next video we are going to talk about translation of the graphs.